I'd also like to show you two different solutions for number 5, the flask. We're going to start with the formula, pi over 3 r squared h. And as we discussed yesterday, all three of these quantities, the volume, the radius, and the height, will be changing as water is entering. So I'm going to have to take the derivative with respect to time for all three of those variables. Considering this again a product rule, it's pi over 3 r squared dh dt. So I've taken the derivative of h. Now I'm going to take the derivative of the r squared. There's my coefficient, pi over 3, 2r. I still have that h, and then I've got to remember that dr dt. Okay, now I need to know what the radius and the height are, as well as I've got this dr dt that I have not, I'm not looking for that, so I'm going to have to find another relationship so I can make a substitution for that. I'm going to go back to this information that I gave you yesterday, and I'd ask you to set up a proportion, and I'm going to use that proportion. Let's reduce that. 11 over 3 is equal to h over r. So 11r is 3h. r is 3h over 11. Now this is going to allow me to find an expression for dr dt, but it's going to be in terms of dh dt, and that's one of the substitutions I'm going to make. Now the other thing I mentioned is that I need to know the height and the radius. Back over here. I need to know both the radius and the height. I've got this information. I'm going to be solving for this, and I've just made it, I've found something that I can substitute for dr dt. We're told that the depth of the water when it contains 500 milliliters is 5 meters. So I'm just going to make this. That's 5. Okay, so that would indicate that this orange triangle is extending further down, which means the height of the orange triangle then, because this total distance is 22, this h is going to be 17. So I'm going to make that substitution. Remember that dr dt was 3 over 11 dh dt. And now that I know that that height is 17, I'm going to use this relationship to find the radius at that moment. 11 over 3 is 17 over r. That's going to be 51 over 11 is r. And this is when we have 500 milliliters. Sorry, not able to see that. Okay, so let's go back. I've got 1,000 over 30, pi over 3, 51 over 11 squared, dh dt, oh, this is a 3, and then this is going to be 2 pi over 3, and remember my r is 51 over 11. Okay, when I solve that, I'm going to get dh dt is 0.494 centimeters per second. The alternate method that I'm going to show you, remember, you notice that I had to find an expression for dr dt in terms of dh dt. Well, what I could have done is substituted this expression here for r at this point. Now notice it's still an expression for r in terms of h, so because we know h is changing, that's this r squared is also changing, it's just written in terms of h. So my alternate method would be pi over 3. Let's see, here we're at. R is 3h over 11. So that's going to be my r squared. 3h over 11 is going to be squared times h for, oh, I'm sorry, this is for my volume, not my dV/dt. This is just for my original equation, which when I simplify that, that's going to be 9 divided by 3 pi over 121 h cubed. And now dV/dt is as simple as 9 pi over 121 h squared dH/dt. And again, we know that this h is 17, so 1,000 over 30 is 9 pi over 11, or excuse me, 121, 11 squared, 17 squared dH/dt. Solving this, you're going to get the exact same answer. You'll do the same thing for when the flask contains 1,000 meters. The difference, 1,000 milliliters. The difference is now the depth here is going to be 13.5, so you're going to have to use h as 8.5. Again, then you're going to find your radius in terms, you're going to find a value for your radius if you choose to do this method. But if you choose to do this method, that's all you're going to need.